So today we will discuss about discretization of parabolic equation. Suppose this is a steel rod where in this side, this left hand side, the temperature is at 100 degrees centigrade, and in the right hand side the temperature is at the 20 degrees centigrade. What we want to know is what is the temperature inside this rod or at the internal points of this rod. So for this we have to discretize the heat conduction equation. The heat conduction equation is this: alpha del square 2 del x square equals to del T del T. This T is the temperature, this x is the position or spatial coordinate, which is 0 at the point of application of the heat source, and it moves or it increases towards the right hand side. If left hand side you have given the heat, then it will move towards right hand side, because temperature will gradually move towards this side if this side is cooler. So as this is hotter and this is cooler, and a steel rod is a good conductor of heat, so the heat will start to flow from this side to this side. So that is why we take x as 0 here, and then at the end point you can say this x is x if the length of the rod is x. Now how to see what type of equation is this? You see t here, t is a function of x and time t. This t is time, this x is position. So time means the time increments. So the temperature t is function of positional coordinate x and time t. So let us see, if you compare this equation with the standard equation, partial differential equation. Suppose this will be del square t del x square plus del square t del x del t. This will be b plus c del square t del t square plus d equals to 0. So this is the standard form of partial differential equation of second order. Now here you can see that the coefficient of del square t by del x square is alpha here. So basically a is alpha, and there is no b, and also there is no c. So both of these coefficients are 0. So b square minus 4ac to be equal to, if it is equal to 0, then this equation is a parabolic equation, right? So b square, here b is 0, so this becomes 0, minus 4, a is alpha here, but c is 0. C is 0. There is no del square t del t square term. So coefficient of del square t del t square term is also 0. So this is 0. So this becomes 0 minus 0. So this is 0. So as b square minus 4ac is equals to 0, so this one is a parabolic equation. As we know that if b square minus 4ac is greater than 0, then it's a hyperbolic, and if it is less than 0, then it is elliptic. But here it is b square minus 4ac is equals to 0. As b is 0, c is 0. Although a is alpha, but as c is 0, so it becomes 0. So that is why b square minus 4ac is equal to 0. So it satisfies the condition of parabolic equation, and hence this equation is a parabolic equation. So we can understood that alpha del square t del x square this is a parabolic equation, and this equation actually represents the conduction of heat through a solid pipe. And if I apply some heat here, this heat will transfer to this side, as this is cooler, this is hotter and this is cooler. So when I apply some heat here, so naturally it will be hotter and it will be cooler, and heat will start to conduct through the solid rod from the left hand side to the right hand side. Now, if I want to know what is the temperature at this point, this point, this point, then I have to discretize this parabolic equation. So how to discretize? Now you see here del square t by del x square at I comma j can be written as t I plus 1 minus comma j, or I can write it here also j. So tj I plus 1 minus 2 ti j plus tj I minus 1 divided by del of x square. This is actually the central difference of this second order partial differential equation of del square t del x square. This is actually nothing but the partial differentiation, second order partial differentiation of the temperature T with respect to x. So this is the central difference, and this term can be written as del T by del T at I comma j. This term can be written as T j plus 1 I minus T I j divided by del T. Now, what is this del x and what is this del T? Del x is the spatial increment towards left hand to right hand side. So, if this is a rod of suppose 8 meter length, then if we segment this rod into 4 different segments, but equal segments, right? So, equal segments, so let us say this is 2 meter, this is also 2 meter, this is also 2 meter, and this is also 2 meter. So if I divide this rod, this solid rod, into 4 segments, and each segment of 2 meter length, right, then this del x will be equals to 2 meter. And if I begin this coordinate, this positional coordinate x, if I assume this x to be 0 at this point, where I have applied the heat, then this point, at this point, x will be equals to 8. And At this point it will be 2 meter, it will be 4 meter, it will be 6 meter. And this junction of two different segments is known as node. Junction of these two different segments is known as node. This is your segment, this is your node, right? And we will try to find the temperature at these internal nodes, right? After a certain time, after we apply the heat onto the left hand side of this rod, right? So if I apply this heat at t is equal to 0th second, then we will like to, or we will be interested to know what is the temperature at these nodes and also this edge and also this edge after suppose 3 seconds, after 6 seconds, after 9 seconds, and so on. So if I want to know that what will be the temperature at these internal nodes after 3 seconds, and then again uniformly incrementing this 3 seconds to 6 seconds, 6 seconds to 9 seconds, you can see the difference between T1 and T0, the initial temperature, is 3. Again T2 minus T1 is 3. Then T3 minus T2 is 3. If this is your T0, 3 seconds is your T1, 6 seconds is your T2, and 9 seconds is your T3. So here you see we are incrementing the time of interest by 3 seconds uniform. Hence, this 3 seconds is nothing but this del t, time increment. So this del x is the spatial increment towards x direction, and this del t is your temporal increment. And we want to know what is the temperature at these nodes after a certain temperature del t, right? So here what we want to know is if I take the x as I, then I can say that if I take this temperature I is equal to 0, then I can say that I want, and if this is I is equal to 1, this is I is equal to 2, this is I is equal to 3, this is I is equal to 4, then what happens is if I multiply I with del x, we get the internal length of the rod. Again, if I multiply j with del t, we will get the total time of our interest. This is 9 seconds, right? So if I is the unit of x, then j is the unit of t, right? And your I is actually equals to the number of nodes you are generating, or uh, you have generated by segmenting the rod into 4 different parts, equal parts. So, and if you take I, the initial point as 0, then your I will be equals to the number of parts you have generated by segmenting the rod. Okay, so suppose this, if this is a rod, and if you divide this rod into suppose 4 segments, then your I will be 0, 1, 2, 3, and 4. Your I will be 4. Okay, so as I have already said that if If I multiply I with del x, then we will get the L. Here L is the 8, and if I is 4 and I do not know what is del x is, you can easily find the value of del x by dividing this. So basically del x is equals to L by, and the similar manner as J is del t is the total time t, right? Then to find del t, just divide t with or by j. So this is your del t. Now this is your del x and this is your del t. Okay. So now if we, as we know that minus del t by del t is equals to 0, I can write this as alpha. This is central difference, right? So you can say this as tji plus 1 minus 2 tij plus your tji minus 1 del x square minus tj plus 1I. This is actually forward difference of this term. Zero. Now, as we know that our main objective is to know what is the temperature at the node I after j plus 1 time. So what we'll do is we'll keep this part in the left hand side and take all other terms into the right hand side. So we can say this as minus tij plus 1 minus tij del t is equals to minus alpha tji plus 1 minus 2tij plus ti minus 1j. Let's explain. Now, if I multiply this del t, this is the denominator, to this term. So this term becomes minus alpha del t by del x square. And this will be like tj I plus 1 minus 2t I j plus t j j minus 1 del x square. Right? So, sorry, here there will be no del x square because this is already written here. Now, if this I deduct this minus, right? So this will become a, take this part, this thing towards that side, this t thing towards that side. So what I do, what will be the net result will be tij plus 1 will be equals to tij plus tij. This is a minus term, so what will happen is, so what will happen is tij Now this will become minus tji plus 1 minus 2tij plus ti minus 1 j, right? And this here will be your that alpha del t del x square. So this will be your final equation. However, you can also replace this term alpha del t del x square to tij minus lambda, then this term. So if I want to know the value of temperature at I after j plus 1, what we need is we need to know the value of temperature T at I plus 1 and at I minus 1, or on the node I plus 1 and node I minus 1 at the time T is equal to J, right? So with the help of the values of temperature at the nodes I plus 1, I and I minus 1 at the initial time scale T, we can know what will be temperature at the node I after del T, right? So this is what we want to know for that steel rod and its nodes. So overall, this is the problem. So this is the rod. I have applied some temperature 100 degrees centigrade here, and in this side the temperature is 20 degrees centigrade. So the heat will flow from this side to this side, right? And this is I have earlier discussed about 8-meter length of rod. So let us say this is a 10-meter length. So as I have said that your I into del x will be equal to 10 meter, right? Right. So del x, we are saying that it will be 2 meter. So I will be 5. So there will be total number of nodes will be 5, including the edge nodes, right? Or if I take the left hand side node as 0, then there will be total number of nodes will be I is equal to 5, right? So if we begin from 0, we will end on 5, right? So this can be found out from here. I is equal to 10 meter by del x, and del x is equal to 2 meter, so I can say I will be equal to 5, right? So in brief, the entire thing that I have already discussed is written here. So you can go through it again. This Txx is nothing but del square T by del x square, and this Tt is nothing but del T del T, right? So it is the same. So here they have discretized and put it into this equation. After that, this is the resultant. Ultimately, final equation comes like this, right? Now, our problem is, as I have already discussed, that I want to know the temperature at each nodes I. At what is the temperature at I is equal to 1, I is equal to 2, I is equal to 3, 4, 5. So here it is written for a time increment of 3 seconds. That means length of the steel rod is 10 meter, left edge is given 100 degrees centigrade, right edge is given 20 degrees centigrade. Our question is, what will be the temperature of the internal nodes? This thing. After 3 seconds, 6 seconds, and 9 seconds. So notice at the initial time, J is equal to 0, what are the temperature of ice? I at the nodes. So what is the temperature of I is equal to at I is equal to 0? 100 degrees centigrade. This is given. This is also given. But all these we have assumed, right? And we have to know what will be the temperature at those nodes after a first time increment. This is actually 0 plus 3 seconds. After second time increment, 0 plus 6 seconds, and after third increment, 0 plus 9 seconds. Here also, as you know, that J into del T is equal to the total time T. So if I know that this T is 9 and this del T is 3 seconds, then the segment of time scale will be J is equal to 9 by 3 seconds. Right? So that is why we are adding, this is 0, this is the first initial temperature. Then we are adding 3 seconds to get the first increment, again 3 seconds to get the second increment, again 3 seconds to get the third increment. So problem is to know the value of temperature at the nodes, all these nodes, after first time increment, second time increment, third time. So this is the basic problem. So how to solve it? It is very easy to solve this type of problem. You see, this part is known, this part is known, and we have assumed that all these nodes are at a temperature T is equal to 20 degrees centigrade. All this at the initial time at T is equal to 0 second. Now here you see, first take this part. So J is your 0 second initial time. This is 0 second. This is also 0 second. Now what is the temperature at 0 second for I plus 1? So if I assume that I is equal to 0, then what is the temperature at I plus 1? It is 20 degrees centigrade. This is your I plus 1. So this value will be 20 degrees centigrade minus 2 into Tij. So this minus 2 into Ti, this I is this one, I is equal to 0. So at I is equal to 0, so your T is 100 degrees centigrade. So this will be your 200 degrees centigrade. And there is no I minus 1 term here, so this term will be 0 total. So here what I found is, this part will become, this is 20 degrees centigrade minus 200 degrees centigrade. So this will ultimately be minus 180 degrees centigrade. Right? So here, now let us see this one. For this Ty, this is straight away 100 degrees centigrade. Because at I is equal to 0 and J is equal to 0. Right? So this part is minus 180 degree. So this equation, this entire equation will become 100 degrees centigrade minus 1/8 lambda into 180 degrees centigrade. Now here, what is lambda? Lambda is equals to, I have already discussed about this, alpha del t by del x square. Now I know what is del t. Del t is our 3 second. Del x is our 2 meter. So only thing unknown is alpha. Now this alpha will be given, or you can find it out by alpha is equal to basically this will become alpha is equal to L by L by P L by P omega. So as we can know that alpha is our K by rho C, and all this will be given. K will be given, rho will be given, C will be given. So you can know what is alpha, right? So after then lambda will become alpha into del t by del x square. So here del t is your 3 seconds and del x square will be 2 into 2, that is 4 meters, right? So, and we have already find out that this is your t I at 0, j plus 1, this is j is 0 and plus 3. So this becomes t at 3 seconds, temperature at node 0 at 3 seconds, or after 3 seconds will be equals to 100 degrees centigrade, which is basically the T temperature at node 0 at 0th second initial time minus lambda 180 degree centigrade. And if the value of lambda can be known from this. You know the value of alpha, you can know the value of lambda, and accordingly you take. So by this way, you know what is the temperature at I is equal to 0 for j is equal to 1, right, after 3 seconds. Now you will try to find what is the value temperature at point I is equal to 1 at the same time scale. But this time I will be your 1. Okay, so again you will know, repeat this step for I is equal to 2, then I is equal to 3, then I is equal to 4. As there are 5 segments, I is equal to 5. At the same time increment of 3 seconds. Now let us take the example for I is equal to 1. So here, as you know, I have already find out the value of t at I is equal to 0 after the first increment. So this one I have found out. Okay. Now my next question will be, what is the value of t on the point or on the node 1, first node, this one, and after the point, after the time increment of 3 seconds, first time. So let me put these values here in this equation. What is Tij? This j is as usual, this is 0 second, but this I is here 1, right? So what is the value of t at I is equal to 1? We have assumed it to be 20 degree, right? Now lambda, as we know, I have discussed already, lambda is equal to alpha del t del x square. Here del t is your 3 second, del x square is 4. And instead of alpha, we can write this as k by rho c. And if you know the k, rho c, then you can find the value of alpha, right? Now, so what is the value of ti plus 1? I plus 1 means this is your I, this is your I plus 1, this is your I minus 1. So this I plus 1 will be actually 20 degrees centigrade because we have assumed at the beginning that all these nodes are at 20 degrees centigrade at the initial time. So here 2 Tij, we have already calculated 2 into 20 degrees centigrade because this Tij is 20 degrees centigrade as per our assumption. However, this Ti minus 1, that is temperature at this node, this is I minus 1, right? This is I and this is I minus 1. So this side is positive, this side is negative because it is flowing from this part to this part, right? So this is I minus 1, so which is known as 100 degrees centigrade. So if I see this, this is 20 degree minus 40 degree, that is minus 20 degree plus 100 degrees centigrade. That means this will be equals to 20 degree plus lambda. This is 20 minus 40, 20 plus basically this is 120 minus 40, 80, right? 80 degrees centigrade. This is 20 degrees centigrade. This is your 20 degrees centigrade. This is your 100 degrees centigrade. This is positive, this is positive, so positive, positive. We add it, we go 120 degree. The minus 2 into 20 degrees centigrade means this is 40 degrees centigrade. So 120 degree minus 40 degrees centigrade comes as 80 degrees centigrade. If I know the value of lambda, that means if I know the value of alpha, then we can find out this value. So this one is also known. Now, like in the similar manner, now this I plus 1, I is equal to 2. Then this I plus 1 will now become I. This will become I plus 1, and this will become I minus 1. So, accordingly, this is 20 degrees centigrade. This is 20 degrees centigrade we have assumed. So, we can find out what is this temperature is. Then we have to move ahead to node 3, then node 4, and add lastly node 5. Now remember at node 5, this 20 degrees centigrade is not assumption, this is given, right? So here at j is equal to 1, you can find the temperature at all these nodes with the help of this process. If we know alpha, if we know k and q, rho and c, you already know del t and del x squared, so you can easily find out what is the value of lambda and you can do it. So after finding the temperature at all the nodes after 3 seconds, then you try to find the temperature at all the nodes after 6 seconds and then after 9 seconds. So after that, what we have to do is, we already know what is the value, these values, we already know that these values are assumed. So what happened is, when you are trying to find out these values based on the assumed values, there are bound to be some errors, right? So next session, what will happen is, After you have find out the value of temperature at all nodes at time j is equal to 1, j is equal to 2, and j is equal to 3, we repeat the calculation again. Okay? So we again repeat it, right? And try to find the values again for the 3 second, for the 6 second, and 9 second. Then we try to find out the error with the help of this formula. T previous minus T new or present divided by T previous. So this gives the error of the iterations. And we try to minimize this iteration, try to minimize the error, try to reduce the error in each iterations, right? So now how you can find out when the solutions are stable, when solution has converged to the accurate solution, how to find it. So for that, please watch my previous video on convergence and stability of partial solution to partial differential. Okay, and also you see that to find out the t previous to t present, so what in case of t previous and t present, always remember that t present is the second, is the present iteration, t previous is the last iteration. So this we may conclude this presentation. So in summary, in conclusion, what I can want to say is our problem is we have to find the temperature at all these nodes for the steel rod where we have applied 100 degrees centigrade in this part. This is your T left, and then if the temperature will increase in this part and slowly move towards this part, and we know that this at this age T right, the temperature is at 20 degrees centigrade. So we want to know what is the temperature at the internal nodes. So these nodes are nothing but the junction point of the equidimensional segments into which we will divide this steel rod. So each of these segments we have created out of this total, out of this solid rod. These segments are equal in dimension. All are del x, del x, del x, del x. And what we have done is, in the example, the length of this rod is 10 meters. So we have generated five nodes or five segments. Actually, there will be 6 nodes if I include the 0th node also. If we are generating 6 nodes, then we are creating 5 segments. If we are creating 4 segments, we are creating 6 nodes. Okay. So always nodes, number of nodes is equal to segment plus 1. This is a common relation. Right? So what we have done is we have created 6 nodes out of 5 segments. The nodes are at the junction point or edge points of the each segments. And Naturally, each of the segment is of 2 meter length. As I am saying that all these segments are equal to each other, right? So your del x is 2 meter, and we are dividing the time scale also by equal dimension, equal increments. So what we are doing is we are incrementing the time by equal increment of del t, and suppose this is 3 seconds, right? So if time increment is represented by j and space increment is dependent by, sorry, not, this time increment is represented by j plus 1 and the space increment by I plus 1, that means I is the positional coordinate and j is the time coordinate, temporal coordinate, right? So to find out what is the temperature at all these nodes after a time increment of 3 seconds, we have to use this equation. This equation has come out from this equation, which is nothing but a heat conduction equation, which is a parabolic equation, and we have discretized the two terms of this equation. This first term, which is the del square t del x square term, is divided into central difference, and this is another term del t del t. This was forward difference was used to discretize the this term, right? And then we have combined all these two terms, the discretized term txx and dt, because this is the equation alpha txx minus dt equals to 0. And then we have found ultimately by rearranging what we have found is this one. So now what we are doing, our problem is this, right? I know the temperature at I is equal to 0 to 5 at the initial time scale. I know only the edge temperature. This is T left hand, this left edge and right edge. These two are known. But all these four, 1, 2, 3, 4, is assumed. It is assumed to be 20 degrees. Now what I have to do is I have to find out this term, what is the value of this term, what is the value of this term, what is the value of this term, and what is the value of this term. And not only this, I have to also find out what is the lambda. Lambda is actually alpha del t by del x. Del x you know 2 meter and del t is 3 seconds. So this part is also known, right? But you do not know what this is. To find it out, you have to find out k rho c. So these the values of this constant will give you the value of alpha, right? Once lambda is known, then you can find out what is this. So here Ti at the first stage I is equal to 0. Ti will be your 100 degree centigrade because this is given. Then lambda, then Ti plus 1, I plus 1 will be this one. So I plus 1 is, we have assumed that this will be 20 degree centigrade because these temperatures are of the previous time scale. So J means the initial time scale. This time. We are trying to find out the T, the temperature T at the next time scale, next time increment, with the help of the temperature values of that node or the other nodes, adjacent nodes, at the previous time scale. So that is why this equation is example of explicit equation, because with the information of a previous domain, time domain, we are trying to find out the value of the variable for the next domain. All these are at t, and at t is equal to 0th second or jth second, except the output one. This is equal to j plus 1. because I have to know the temperature after the time, desired time. Right, so you know what is I, T, I at I. Then I plus 1, this I plus 1 will be here. This was assumed to be 20 degrees centigrade. So this will be your 20 degrees centigrade. Again, they are saying that what is the temperature at ith node. So this is your already known. So this will be 200 degrees centigrade. And then I minus 1, there is no I minus 1 for the node I is equal to 0. So this term is 0. So similarly, you will find out the value of I is equal to 0 and j is equal to 1. Now, if you want to try to find out the value of I is equal to 1, so this is your I is equal to 1. This now becomes I minus 1 and this becomes your I plus 1. Accordingly, you put it into this equation and try to find it done. In this way, you can find that I1, I equal to 1, I equal to 2, I equal to 3, I equal to 4, I equal to 5. For the time increment of 1, first time increment, then you find out the second time increment, and then you find out the third time increment. After finding all these things, remember this part is assumed. This is not real part. So what we do again repeat the iteration from j is equal to 1. And try to find out the error by t, the formula t previous minus t present divided by t previous. This is a relative error, and based on this relative error, we try to repeat the iterations. So with this, I will close.